In this lesson, we'll be reviewing adding and subtracting fractions and mixed numbers using an algorithm, meeting the requirements for TEKS 53H and 53K. In this lesson, we'll be using an algorithm to find sums and differences for addition and subtraction problems involving fractions and mixed numbers. We won't be modeling. We won't be drawing rectangles or bars. We'll be using a set of rules or steps in a process. That's what an algorithm is. The steps in this process require us to rewrite the fractions in our problem with common denominators. To form common denominators, we'll be looking for what's called least common multiples. We're going to use this in order to rewrite our fractions in an equivalent form with common denominators. Once we've done that, we'll simply add or subtract the numerators to arrive at our solutions. I'm going to show you plenty of examples. Let's take a look. Our first example is 1/2 plus 2/5. Now, in the lesson I did on adding and subtracting fractions and mixed numbers using models, I showed you that the solution or sum to this problem was 9/10. Let's see if I can show you how to arrive at the same correct answer using the algorithm. The algorithm says rewrite your fractions so they have common denominators. I need to rewrite the fraction 1/2 and the fraction 2/5 so they share the same denominator. And here's how we do it. We look for what's called the least common multiple. We look for what's called the LCM. The LCM is the least common multiple. I find multiples of 2. 2, 4, 6, 8, 10, 12, 14, and multiples of 5. 5, 10, 15, 20, 25, 30. And then I look to see if there's a number on both lists. And in fact, if I look, I see the number 10 is on both lists. In fact, it's the lowest number that's on both lists. That makes it the least common multiple. The least common multiple will become my new denominator. So I'm going to change the denominator of both of my fractions to 10. So then the question becomes, what did I do to 2 to make it become 10? And if you said, well, I multiplied it times 5, I'd say you were right. I'm going to do the same thing to the numerator. So 1 times 5 is 5. So that 5/10 is exactly the same value as 1/2. I have rewritten the fraction 1/2 into an equivalent value fraction of 5/10. What did I do to 5 to make it 10? I multiplied by 2. So what will I do to the numerator to make my new numerator? I will multiply it by 2. And 2 times 2 is 4. I now simply add my numerators. 5 plus 4 is 9 over my common denominator of 10, so that I know 1/2 plus 2/5 equals 9/10. In our next example, we'll subtract 2/3 minus 2/5. Our algorithm is exactly the same. I need to rewrite these fractions having common denominators. So I need to find multiples of 3, 3, 6, 9, 12, 15, 18, 21, and multiples of 5, 5, 10, 15, 20, 25, 30, 35, and find a number that's on both lists. I see 15 is on both lists. 15 is the lowest number on both lists. That makes 15 the least or lowest common multiple. 15 will become my new denominator. How did I make 3 into 15? I multiplied it by 5. So what am I going to do to 2? I'm going to multiply that by 5 as well. And so 2 will become 10. How did I make 5 15? I multiplied by 3. So what am I going to do to the 2? The same thing. And 2 times 3 is 6. And now I simply subtract. 10 minus 6 is 4 over my common denominator of 15. So my solution, or difference, is 4/15. 2/3 minus 2/5 is 4/15. If you look back at the lesson on adding and subtracting fractions and mixed numbers using models, you'll see I've arrived at the same correct solution using the algorithm. So how does the algorithm work when we're dealing with mixed numbers instead of fractions? And I would say it works in a very similar way. First, we're going to ignore the whole numbers. We're going to leave those alone for right now. Now, we're going to come back to them. We don't want to forget about them, but for now, we're going to leave them be. We want to focus on finding common denominators. I need to find multiples of my denominators. So 2, 4, 6, 8, 10, 12, 14, 16, 3, 6, 9, 12, 15, 18, 21. Hey, I need to find a number that's on both lists. I see 6 and 6. Now I also happen to see 12 and 12. Both numbers are on both lists. But remember, we're looking for the least common multiple. We're looking for the lowest number on both lists. So that means we're going to use 6. 6 will become our new denominator. Now, I bring down my whole numbers because I'm going to remember to include them. I don't want to forget about them. We're adding, so now I need to look at my fractions. How did my denominator of 2 become 6? Well, multiplied by 3. So what do I do to my numerator? The same thing. What's 1 times 3? 3. For 1 1/3, how did 3 become 6? Well, 3 times 2 is 6. So my numerator of 1 would become 2, because 1 times 2 is 2. Now, we add the fractions first. We know our denominator is 6. We add our numerators. 3 plus 2 makes 5. After I've added my fractions, I now have to remember to add my whole numbers. 2 plus 1 is 3. So that 2½ plus 1 1/3 is 3 5/6. Now, what happens if we subtract using mixed numbers? And I would say we're going to use the same algorithm to arrive at a correct difference or solution. First, we're going to leave our whole numbers alone. We're not going to eliminate them. We're simply going to ignore them for a minute and come back to them later. First, we're going to find the least common multiple. We're going to find multiples of the denominators. 6, 12, 18, 24, 30, 3, 6, 9, 12, 15, 18, 21. Now I can see already, I see 6 is on both lists, 12 is on both lists, 18 is on both lists. There are a lot of common multiples shared by 3 and 6. But if you remember, we're only looking for the least common multiple. We want the lowest number on both lists. So we're going to use 6. Now, we bring down our whole numbers. We don't want to forget about them. It's time to bring them back in. We're subtracting. Now, going to our fractions. How did 6 become 6? Well, it never actually changed, did it? So I must have multiplied it by 1. 6 times 1 is 6. So I'll do the same thing to the numerator. 5 times 1 is 5. You can see that the fraction in our first mixed number didn't change at all. And that's because the least common multiple was the denominator that this fraction already had. But in our other fraction, we did need to make a change. 3 became 6 by multiplying by 2. So 1 times 2 would be 2. We subtract the fractions first. 6 is our common denominator. 5 minus 2, subtracting the numerators, 5 minus 2 is 3. Now we know we can simplify 3 over 6. We can divide 3 and 6 by 3. And 3 divided by 3 is 1, while 6 divided by 3 is 2. And now when we subtract our whole numbers, 3 minus 2 is 1. So that our solution, 3 and 5/6 minus 2 and 1/3, has a difference of 1 and 1/2. How about an example with a mixed number adding a fraction? Once again, we're going to leave any whole numbers alone in the very beginning, and we're going to simply search for multiples. 3, 6, 9, 12, 15, 18, 5, 10, 15, 20, 25. And I see that 15 is on both lists. It's the only number on both lists, but of course that also makes it the lowest number on both lists. So 15 will become our new denominator. 15. Okay? We bring down our 1, because we don't want to forget about it. And now we look at our denominator of 3. How did 3 become 15? Well, we multiplied by 5. So we'll do the same thing to the 1, our numerator. 1 times 5 is 5. When we move to our fraction, how did 5 become 15? Well, we multiplied by 3. 5 times 3 is 15. So we'll do the same thing to the numerator. 3 times 3 is 9. And now we'll add. We add across the numerators. So we know our denominator is 15. 5 plus 9 is 14. And now we add our whole numbers. I have a 1, and then I don't have a whole number, so 1 plus no whole number, or 1 plus 0, is 1. So that 1 and 1/3 plus 3/5 is 1 and 14/15. Let's go ahead and wrap up this lesson. In this lesson, I showed you that you can add and subtract fractions and mixed numbers using an algorithm. An algorithm is a set of rules or steps in a process that if you use these steps repeatedly over and over and over again in the same way, you will arrive at sums and differences, correct solutions to addition and subtraction problems every single time. The first step in this algorithm is to rewrite their fractions with common denominators. So when we had fractions like 1/2 and 2/3, we needed to find common denominators. 2 and 3 are totally different denominators. And the way we did it was by searching for the least common multiple. We made a list of all the multiples, and then we looked for the lowest number on each list. When we found that number, we knew that needed to be our new common denominator, and we rewrote our fractions. They're equivalent values. They're still the same value. They just look different because we've changed the size of the denominator. So 1/2 would become 3/6, just like 2/3 would become 4/6. And now that they share the same number of pieces, their denominators are the same size, we can add or subtract depending on what the problem is asking us to do. An algorithm, steps in a process, can be used to repeatedly find correct solutions to problems.